Archaeologists solve mysteries for a living. They spend time literally digging up clues that can help them piece together stories from human history. Archaeologists can find all sorts of objects, known as artifacts. All of these objects have their own story, but some artifacts might appear more precious than others. Here are just 3 examples of what archaeologists might be lucky enough to find. Maybe they'll discover a dazzling gold brooch, perhaps belonging to a wealthy citizen of some forgotten empire. Or maybe a sword, used by a soldier in historic battles against an enemy. Or maybe archaeologists will find a collection of pieces of broken pots. So, which one would you be most excited to find? I certainly know which one I would pick. Can you guess? Well, the most precious object to me would be the broken pots. Yes, I know what you're thinking. Why on earth would I pick a load of boring old broken pots? Because, for me, they have by far the most interesting story to tell. Let me show you. Yes, they might not be much to look at, but they have an interesting invisible history hidden inside them. What were these pots used for? Were they used for cooking? Or maybe for storing precious food items? All of these thoughts lead us to the ultimate question that these pots might help us answer. What were humans eating in past civilizations? We don't know the answer to this just by looking at them, but with the help of chemistry, we can find out. I'm Sophie. I'm a research scientist, and I use chemistry to help me solve mysteries of the past. Take this broken pot, for example. It might not give us any obvious clues to piece together its story just from looking at it, but it very well may have some invisible clues for us to investigate. From decades of scientific research, it's been found that historic cooking pots can absorb chemical compounds throughout their lifetime. As the pot is used for cooking, for example boiling and processing a variety of different foodstuffs, organic compounds from those foods are released into the mixture and are absorbed into the pot's ceramic walls during use. They then become trapped in the ceramic wall and are preserved over time. The most commonly preserved compounds are lipids, which include fats and oils released by food as it's cooked. Lipids are stable enough to survive over hundreds and thousands of years, and so can be analysed by us today, which is good news for archaeological scientists. Once in the lab, we can clean a small area of the pot, take a small sample and grind this down into a powder. Then, by adding a few chemicals and after a few experimental steps, I won't bore you with the details here, all of the lipid compounds that were trapped in the ceramic wall are released in the solution. So now, we have something we can start investigating. At this stage, we use the technique known as gas chromatography, which allows us to separate out each of our lipid compounds. We can then go on to use mass spectrometry, which allows us to identify what each of those compounds are. And here is where the fun begins. For archaeological cooking pots, all sorts of lipids have been identified from a range of natural sources. Let me show you a few examples. Perhaps the most commonly found compounds are fatty acids, deriving from animal fats, from the cooking of meat products, from cows, sheep and pig, as well as the processing of dairy products. The discovery of these lipids helps archaeologists figure out what sort of farming was taking place, and what animals past communities relied upon for food and trade. We might also come across some aquatic fats, showing that fish have been cooked in the pots. Because of some distinct organic compounds of aquatic plants and algae in the food chain, fish oils have a few key lipids we can look out for. Identifying these compounds therefore tells us fishing practices were used by the community, particularly if lakes or rivers are nearby. Another interesting product that past humans made use of is beeswax, a substance made by honeybees for their honeycomb structures for storing pollen and honey. Beeswax has a complex mixture of lipid compounds, but there are a few distinctive chemical signatures we can look out for. Alongside the obvious use of honey as a sweetener for humans, beeswax itself has been used in prehistory for a variety of reasons. As a sealant and for waterproofing ceramic vessels, in lighting such as candles, and even in cosmetics too. Not to mention, these clever little honeybees also help to pollinate plants and crops, and are still helping us with food production today. Speaking of plants and crops, the discovery of compounds known as alkanes is often a good indicator of plant processing in the pots, and points to people eating leafy vegetables. There are also a few compounds specific to cereals and grains that have been identified, and all of this helps us in understanding what food crops were key in the agricultural lifestyle of past communities. This has been just a brief glimpse into what substances an archaeological pot might have encountered over its lifetime, and what chemistry can do to help bring its story back to life, hundreds or even thousands of years later. So, if you're ever fortunate enough to be on an archaeological dig and stumble across some shimmering golden jewels or legendary swords and weaponry, don't be surprised if there's a chemist who's more excited to uncover some dusty old pots.